Hi, everyone, and welcome back from the weekend. I hope you had a great one. And now we only have one more week until spring break. Woohoo! So today we're going to be covering something that we've already covered. We're just going to be reviewing it and then using that new independent and dependent vocabulary. So we're going to be taking tables and we're going to be writing equations. Remember that when we write equations, it's usually something like y equals 3 times x. Okay, but now we have that vocabulary where y is always our dependent variable and x is our independent variable. Okay, y is our dependent, x is our independent. And so in this problem here, we have Jenny and she's going out and she's walking dogs. She can walk one dog or two dogs or three dogs. And now we're going to learn how much she's going to earn depending on how many dogs she walks. So remember, when we see a table like this, our x comes first, our y comes second. And I make sure to mark that so I know the independent, which is the dogs walked, and the dependent, which is earnings, which makes sense. If I'm walking dogs, I can choose how many I walk, and then y, my amount of money, depends on how many dogs I walk. Remember, y depends on x is independent, y is dependent. Okay, so now that I know my independent and dependent variables, I know my x and y, I can go ahead and look at this table and I can complete this table because let's see what happens. When she walks one dog, she makes $8. When she walks two dogs, she makes $16. When she walks three, she makes $24. So think about a pattern. What's happening depending on the x, how much money I make? Well, we're multiplying by a number. And we're multiplying by 8. And if you can see here, 1 times 8 is going to give me 8. 2 times 8 is going to give me 16. 3 times 8 is going to give me 24. That means if I walk 5 dogs, I'm going to multiply that by 8, and I'm going to make $40. If I would walk 10 dogs, which would be insane. I'm not sure how she's going to walk 10 dogs. She might have to just strap them around her waist or something. If she would walk 10, she would make $80. And if she would walk 20, I really hope she's not walking all these dogs at the same time. But if she was, or maybe she did that throughout the week, but if she had walked 20 dogs, she'd make $160. So do you see the pattern there? We're multiplying by 8 every time. So when I write my equation, remember I start with my dependent, my y equals, and I'm going to take my x and I'm going to times it by 8. Y equals x, my dogs, times $8 is going to give me the amount I earned. Now, that doesn't look very pretty. Remember, the way that we like to write it would be y equals 8x. And we can do that because of commutative property. Okay, so you've kind of seen what we're going to be doing, our independent, dependent, and writing our equations. Let's look at this next table. We have x and y, so our independent and our dependent, and now we are going to look at what would be our pattern. What's happening from our x to our y? Pause the video, and I want to see what you can come up with. Pause the video, try to write your own equation for this. What is happening in this problem? Okay, this one was a little bit trickier, but what I noticed is that every time I'm really multiplying by 0.5, or I'm taking half of each number, multiplying by 0.5. Because if I took 2 times 0.5, it's going to give me 1. If I take 3 times 0.5, it's going to give me 1.5, and so on and so forth. So my equation would be y equals 0.5 times x. Okay? All right, I want you to look at this next one here, and I want you to try it. Pause the video, try this one, and then I'll come back to you with a discussion about it. Well, if you look at this one here, we can see that to get from 2 to 5, I could multiply by 2.5. But if I went and I looked at 4 to 7, multiplying by 2.5 isn't going to work. So what I did see, though, is that I add 3 every single time. So that would give me the equation y equals x plus 3. Pretty spiffy, huh? Okay, what I would like you to do is I would like you to try these next 6 problems. So pause the video, try the next 6 problems, and then I'll come back and we can check our answers together. Okay, I really do hope you paused the video and tried this. Let's talk about that first one. The first one was a little different because if you notice, to get from 12 to 10, 11 to 9, 10 to 8, I had to subtract 2. And we haven't seen one of those before. So that was kind of cool that we were subtracting 2 from each of them. On the next one, I noticed that it wasn't an adding, it wasn't a subtracting, so I knew it was going to probably be a multiplying because it's getting bigger. And so I was like, okay, how can I get from 10 to 25? Well, that means I could multiply by 2.5. So it's y equals 2.5x. On this one, I like this one. It was just, again, another subtracting one. We're subtracting by 4 every time to get from 10 to 6. I subtract 4. So that would be y equals x minus 4. And guys, pause the video if you're struggling with any of these, and you can ask me a question too. On the next one, I noticed that first one was 0, 0. So that gave me a hint that it was a multiplying problem. Remember when we hit 0, 0, multiply problems. And then 1 to 4 is times 4, so that one wasn't too bad. This one was pretty slick, just y equals x plus 3. And this next one was cool because it was actually a division problem. At first I thought it was minus 10 because it was 12 to 2, and I thought, oh, I could subtract by 10. But really then when I got going, I was like, oh, wait, I'm trying to get smaller, but I can't subtract the same number every time. So I'm going to have to divide by something. And so I said, oh, if I divided by 6, that would work out well. Okay, so what I would like you to do is I would like you to try number 10. Pause the video, and I'm not even going to go through that one with you. Pause the video, go ahead and do it, and then we'll move on to the back side together. Okay, on the back side, I put a bunch of different types of star questions. So in the first one, it's talking about Alice, and she's making some money, and it's in a vertical up and down table. So please don't forget that when it's in a vertical up and down table, it still works the same way as when we were in the horizontal table, that x is going to come first and y is going to come second. Now, they did use d and w, which is fine, but know that that means the same thing as x and y. So I know when they write an equation, it's going to have to be y equals, which means that y is the same thing as w, what they're saying here. So it's going to have to be a w equals problem. I was hoping that could maybe eliminate some of my answers, but it did not. So now I need to really look at my table and see what's happening in between the x to the y and see which of these equations would work. So I want you to pause your video and try it yourself. Pick which one, and then we'll come back together. Okay, I got J for my answer because it was subtracting. I would like you to try these next 2 problems, please. Pause your video, and then we'll come back and check our answers. Okay, in the one about Mr. Martinez, they gave us a table, but now they're asking us to match a situation with the table. So I started at the bottom because sometimes I think they're going to try to trick me like that. And it said Marion had 6 times the number of trains that Tony has. So if it was 6 times, that would mean that we would multiply by 6 every time. So for D, are we multiplying by 6? Nope, so I'll eliminate that one. The next one about James. James read 0 books in the first 6 months, so I thought, oh, maybe. And then he started to read 1 book each week. Well, that was confusing to me. We're doing weeks, but we had months, and I have no idea what that even is trying to talk about. Weeks, months, we're not comparing the same thing. Remember, we have to multiply or divide or add or subtract by the same number. We can't go from months and then all of a sudden to weeks. It doesn't work that way. Beatrice ran 1 mile the first week and then 1 mile each week after that. So if it was 1 mile in the first week, how could we have something at 0, 6? That wouldn't work. And so finally, the one about Rachel. She had $6. So at time 0, she had $6. That makes sense. And then each week she added $1 more. So week 1, she'd now have 7. Oh, that makes sense. Add 1 each time. That makes sense to me. So it would be A. Okay, and on the last one, I thought this one was pretty easy. The first 2 were definitely a no-go. And then on the second 2, the only one that consistently added 10.1 was B. All right, good job. You guys are going to scan that code, and then we will meet up at the next one. Scan the code and play that game. Good job.